Okay, in today's video, I'm just going to go through some more identities. Again, the more you practice verifying these identities or proving these identities, just the better off you'll be next year in calculus, because we get a lot of trig expressions that we have to deal with. And so you want to be able to simplify them. And so the more practice you get, again, just the better you'll be at them. Okay, before we get started, I want to take this time to say I really appreciate those of you who are watching these. I know it's not the most fun thing to do to watch, a math video while you're just sitting at home. I definitely miss being in class. Like me teaching to an empty room, just recording it is not nearly as fun for me either. I miss, interacting with you guys. And even though this year, first and second period were kind of lame, like at least third, fifth, and sixth period were better, and I ended the day well. So anyways, I appreciate you guys watching this, and so let's get started. So I'm going to do some identities, and then I'll have an assignment on Aries for some identities for you guys to practice. We're not going to do that many because in this section, some of the identities have to do with some of the things I told you we were going to skip in this section. And so we're only going to do 4 in this video, so this should be a fairly short video. And then your assignment, I think, will only probably have about 4 identities. So I'm going to start off with this one. Let's see what we get. We have cosine squared 5x minus sine squared 5x, and that's equal to cosine of 10x. Okay. Keep in mind, in this section we learned a few different identities, the half angle formulas, double angle formulas, and then we also know from the previous section the sum and difference formulas, and then all the other ones before, the Pythagorean and so on. So we know a fair amount of identities at this point. So when I'm trying to show one side equals the other, I really try to think about what identities I could use to really show this. Now, I'm actually going to work with the right-hand side on this problem, okay? I think working with the right-hand side of this problem will be the easiest way to show it in steps. Like I could work on the left-hand side, but if I work on the left-hand side, it's almost going to be so easy that you're going to be like, wait, you didn't really do anything. Okay, so I'm going to choose to work on the right-hand side, and I'm going to rewrite the right-hand side as the cosine of 5x plus 5x. Okay, so I think you'd agree cosine of 10x is the same thing as cosine of 5x plus 5x. And we have a formula for that, right? We have an identity, it's a sum and difference identities, and so this is the cosine of a plus b. So what does the cosine of a plus b look like? Well, remember, that turns into the cosine of a times the cosine of b. Let me rewrite this, I'm running out of room here already. If I have the cosine of a plus b, that's the cosine of a times the cosine of b minus the sine of a and the sine of b. And since a and b are both 5x, I get cosine 5x times cosine 5x minus sine 5x times sine 5x. Well, cosine times cosine, since the argument's the same there, cosine of 5x times cosine of 5x is really cosine squared 5x minus. And then the same thing with the sines. Sine 5x times sine 5x is sine squared 5x. And that's exactly what I was trying to get on the left, and so we're done. Okay, so pretty simple. These identities will have similarities to the other ones we've already done, but these ones will probably require you to use some of the more recent identities we've put into our notes. Okay, so let's look at this next one. I have sine x plus cosine x squared, and that's supposed to be equal to 1 plus sine of 2x. So I got to pick a side to work with. I think the left-hand side looks better this time because I can square that binomial. And so this is really like a plus b squared. remember a plus b squared is really a squared, so in this case it would be sine squared x, plus 2ab, so 2 times sine cosine, so 2 times sine x cosine x, plus b squared, which in this case is cosine squared. Okay, that's just basics. We did that way back in the beginning of the year. If I have a plus b squared, it's a squared plus 2ab plus b squared. And from here, well, I have sine squared x plus cosine squared x. At this point, if you've been doing all these identities, you should recognize that that's just equal to 1. So now I have 1 plus 2 sine x cosine x. That's not quite what I wanted yet, but now I have a 1 here, and I'm supposed to get a 1, so I'm good there. So now the only difference is, here I have 2 sine x cosine x, and here I have sine of 2x. But what is sine of 2x? That's a double angle formula, okay? We have a double angle formula we put into our notes. Well, what does sine 2x equal? If you go back and look at your notes, sine of 2x literally just equals this expression right here, which means I can rewrite this as 1 plus sine 2x, and then we're done. Okay? If you're lost on that, go back and look at your double angle formulas. What does sine 2x equal? Sine 2x equals exactly that. Okay, so now we're done with this one. Okay, let's do another one. I have sine of 4x over sine of x, and that's supposed to be equal to 4 cosine x cosine 2x. So I got to pick a side. I'm going to pick the left because the left-hand side at least has a fraction. I may be able to do something with it. So I have sine 4x on top. Now again, I can either apply like the sum or difference formula here and say, well, sine of 4x is really sine of 2x plus sine of 2x. Or I can apply the double angle formula there. It doesn't really matter. I think I'm going to do the sum formula there just so because it's a little bit more explicit. It'll make a little bit more sense onto what we're doing. So again, remember the sine of 4x, I could always rewrite that as the sine of 2x plus the sine of 2x over the sine of x. And if I have sine of a plus b, that's the same thing as the sine of a times the cosine of b plus the sine of b times the cosine of a. But in this case, a and b are both 2x, so sine of a cosine of b plus sine of b cosine of a. But a and b were both, like I said, 2x. So really I have sine 2x cosine 2x and another sine 2x cosine 2x. All of this is over sine x still. And so, well, on top I can combine like terms. I have this term and I have it a second time. So what I have is I have 2 sine 2x cosine 2x over sine x. Well, let's see. Looking at what I'm supposed to get, I am supposed to get a cosine 2x, and I do have a cosine 2x, so that part's good, but the rest of this obviously needs some work. So I have sine 2x, I have sine x. You can't cancel those because the arguments here are not the same. The only way I could cancel these is if they had the same angle or the same argument right there. So I got to think, again, cosine 2x is already good. That's what I need. I got to think, what can I do with sine 2x? Well, sine 2x, again, that goes back to my double angle formula for sine. Sine 2x, I can replace that. So let's look. I already have a 2 here. So that 2's still there. But what I'm going to do now is I'm going to replace sine 2x. So again, the double angle formula for sine, in other words, sine 2x, that's equal to 2 times sine of x cosine of x. So I had the 2, I still have that 2. Sine of 2x is equal to 2 sine x cosine x, and then I still have that cosine 2x as well. And then in the denominator, I have sine of x. And now I can cancel out this factor of sine x with this factor of sine x, because those are the same angles, or those are the same arguments there. So sine x cancels out with sine x. So what do I have? I have 2 times 2, which is 4. So I have 4, and then I have a cosine x, and then I have a cosine 2x, and that's exactly what I was trying to get. Okay. Let's do one more. Like I said, there's not a whole lot of identities for us to do in this section, because we didn't do some of the identities that were taught in this section. Because again, like I said, they don't really come up in calculus, and because of the predicament we're in as far as the distance learning, I just don't see the need on spending time on stuff like that. Okay, so let's see, I'll do one more. I'll do this one. I have 2 times tangent of x minus cotangent of x over tangent squared x minus cotangent squared x, and that's supposed to be equal to sine 2x. So I got to pick a side. The left-hand side obviously looks more complicated, therefore it's probably the side I'm going to work with. So again, the first thing I usually look for is any kind of identity. Tangent minus cotangent is not an identity. Tangent squared minus cotangent squared, that's not an identity. There's not really a whole lot to do there. However, before I start doing some of the other things, I do notice that this right here is a difference of 2 squares, right? It's something squared minus something else squared. And I know if I have a difference of 2 squares, then I would get, a plus b times a minus b. And I have one of those factors right here. So if I factor the denominator, I see that it'll cancel out with that factor on top. So that's what I'm going to do first. I noticed that right away. So I have 2 times tangent of x minus cotangent of x. But in the denominator, again, this is a squared minus b squared. So that's the same thing as tangent x plus cotangent x times tangent x minus cotangent of x. A plus b times a minus b, that's really a squared minus b squared. And then that means this factor will cancel out with this factor. And so now what I have left is I have 2 over tangent of x plus the cotangent of x. Well, tangent of x plus cotangent of x, that's not an identity. There's nothing else I really see to do. So now I can go back to, well, what do we do oftentimes when we get stuck? Well, we do everything in terms of sine and cosine. So let's see what that does for me. So I have 2 over, tangent is really sine of x over cosine of x, plus cotangent is really cosine of x over sine x. And well, now I have a fraction plus a fraction, and so maybe I'll just make common denominators there. So the common denominator between cosine x and sine x would be cosine x times sine x. So that means I need to multiply this fraction by sine of x over sine of x, multiply this fraction by cosine of x over cosine of x to give me the common denominator of sine times cosine. Okay. Well, now I have this fraction and this fraction have the same denominator, so I can write it as 1 fraction over the denominator of sine x times cosine x. And I can add together what's on top. So what's on top is sine times sine, so that's sine squared, plus cosine times cosine, that's cosine squared. So now on top of this fraction, I get sine squared x plus cosine squared x. All right, sine times sine is sine squared, plus cosine times cosine is cosine squared. But what's sine squared plus cosine squared? That's equal to 1. So now I have 2 over 1 divided by sine x cosine x. Well, now I have 2 divided by this fraction. Well, dividing by fraction is the same thing as multiplying by the reciprocal. So this is really the same thing as 2 sine x cosine x. I'm trying to get sine 2x. Well, again, this is the double angle formula. What is sine 2x equal to? It equals 2 sine x cosine x, which means I can replace 2 sine x cosine x with sine 2x. And then we're done. Okay, so this will be the last video on identities, at least for now. And then we're going to start doing some other stuff in my next video. I won't post another video after this one until next week. Again, I appreciate you guys doing the math. I did mention on the Google Classroom, I seem to get quite a few video views on YouTube, and I can't tell who's watching the videos or how many times one particular student's watching a video, but I have less than 50% of my Accelerated 3 students turning in or doing any of the textbook assignments. Okay? If you just watch the videos, again, that's great. I'm glad you're watching the videos and taking notes, but like if you don't actually put pencil to paper yourself and try to work these out, you're not going to get very good at them. Okay? I mentioned it in another video, but I think it was a calculus video, not one of your videos. If you just watch me do these, well, yeah, they look really easy because I've done these a million times and I've been doing math for a long time. And so if you just watch me and you're like, yeah, I got that. Well, you probably don't, any more than if I sat down and I watched someone play the piano, I'd be like, oh yeah, interesting, cool. Yeah, it looks easy. Unless I sit down and try to play the piano or whatever, I'm not going to really improve that well. Okay? So you really need to try to do these on your own. Whatever assignments I give you on Aries, whether you need the extra credit points or not, you should do these assignments just for the practice. Again, I'm not trying to give you anything that's just busy work or whatever. I'm giving you stuff that I know that you're going to need. So that, when we're in calculus next year, when things come up, the more practice you have at these, the better and the easier they'll be. You won't be struggling next year in calculus on stuff that's not even a calculus topic, right? Trigonometry is not a calculus topic. It's a topic from prior to calculus. Okay, so you don't want to get to calculus and miss a bunch of problems because you can't do trig. Okay, so anyhow, that's the end of this video. I miss doing math with you, and I wish we could go back and have that time again, but we can't. So again, try to at least do the problems on Aries. I list them on Google Classroom now as well, but really practice these. Thank you.